Good day, everyone. So we are going to tackle about Gay-Lussiac's law. Gay-Lussiac's law states the pressure of a given mass of a gas varies directly with the absolute temperature of gas where the volume is kept constant. It is a special case of ideal gas law. It is a statement in chemistry and physics when two or more gaseous substances combine to form a gaseous compound. The volume of the product is either equal to the sum of the volume of the factors, or is less than and bears in a simple ratio to this sum. This is also called a combining volume. Gay-Lussiac's law is very similar to Charles' law. The only difference between the two is the type of the container. The type of container in Charles' law is flexible, and in Gay-Lussiac's law is rigid or inflexible.
This law was formulated by French chemist Joseph Gay-Lussac in the year 1808. It states that if the mass and the volume of the gas remain constant, then pressure and Kelvin temperature of that gas will be directly proportional. If the temperature of the container is increased, the pressure is increases. And if the temperature of the container is decreased, the pressure decreases. Gay-Lussac law formula is P1 over T1 is equal to P2 over T2, where P1 is the initial pressure, T1 is the initial temperature, P2 is the final pressure, T1 is the final temperature, telling us that the initial pressure of the gas divided by the starting temperature of the gas will always be equal to the final pressure of the gas divided by the final temperature. So we can also do the cross multiply. A gas has its pressure degrees from 762 to 322 at 225 Kelvin. What was the initial temperature of the gas? So to find the initial temperature, the formula we use is T1 is equal to P1 times T2 over P2. So our P1 is equal to 762 multiplied to T2, which is 225 Kelvin over P2, that is equal to 322. So first cancel out the 2 and multiply 760 and 225. We have 171,000. So divided by 320. We have the final answer, 534.375 Kelvin. Example number 2, we have P1 is equal to 29 psi, T1 is equal to 25 Celsius, T2 is equal to 42 Celsius. So to find the final pressure, we have the formula P2 is equal to P1 times T2 over T1. So remember, if our temperature is in Celsius, convert it into Kelvin, just simply add 273. So our T1 now will be 298 Kelvin. Our T2 is 315 Kelvin. So we have 29 psi multiplied to 315 Kelvin over 298 Kelvin. So cancel out the Kelvin and multiply 29 and 315. We have 9,135 over 298. We have the final answer, 30.65 pound per square inch.
Combined gas law. So today's topic is all about the combined gas law. So first, what precisely is the combined gas law? The combined gas law combines the three gas laws, namely Boyle's law, Charles' law, and Gay-Lussiac's law. It asserts that the pressure-volume-temperature ratio of a system is constant as long as the amount of gas does not change. First, Boyle's law is a gas law that states that the pressure exerted by a gas of a given mass kept at a specific temperature is inversely proportional to the volume. In other words, as long as the temperature and quantity of gas remain constant, the pressure and volume of a gas are inversely proportional to each other, where Boyle's law is expressed as P1 V1 is equals to P2 V2, where P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, and V2 is the final volume. Then the Charles law is one of the gas laws that describes the difference between a gas volume and temperature. It states that the quantity of a fixed amount of dry gas is directly proportional to its absolute temperature when pressure is kept constant. So if two measurements are in direct proportion, any transformation in one of them has an instant impact from the other mostly through direct variation. The approximation that expresses Charles' law is V1 T1 is equals to V2 T2, which means V1 and V2 are the initial volumes and final volume respectively. T1 refers to the initial temperature and T2 refers to the final temperature. Both the temperatures are in the units of Kelvin. One example of Charles' law is that in cold weather or environment, balls in helium balloons shrink. It's known that on heating up a fixed mass of gas, that is, increasing the temperature, the volume also increases. Similarly, on cooling, the volume of the gas decreases. And the last is the Gay-Lussiac's. It is a gas law that states that perhaps the pressure placed by a gas of a given mass and kept at a constant volume varies inversely with the absolute temperature of the gas. In other words, whenever the mass is fixed as well as the volume is constant, the pressure exerted by a gas is proportional to its temperature. This law was according to French chemist Joseph Gay-Lussiac in the year 1808.
Combined gas law. How was the combined gas law discovered? In 1834, French physicist Benoit Paul Émile Clapeyron combined the old gas laws into one single law, which was called combined gas law. The ideal gas law is a combined set of gas laws that is a thermodynamic equation that allows us to relate the temperature, volume, and number of molecules or moles present in a sample of a gas.
Problem number 1. A gas has a volume of 800 ml at negative 23 degrees Celsius and 300 torr. What would the volume of the gas at 227 degrees Celsius and 600 torr of pressure? First, we need to set up all the problem values in a solution matrix. You must convert temperatures to Kelvin to use any gas law, including the combined gas law. You only need to add 273 to get the final answer. Next, take the formula and set it up to solve for the unknown x, which is in this problem is V2. We need to cross-multiply to clear the fractions. And we need to divide to isolate V2.
We need to plug in the numbers and solve for V2. We have 300 torr times 800 ml times 500 Kelvin divided by 250 Kelvin times 600 torr. We need to cancel the torr over torr and Kelvin over Kelvin, so the final answer will be ml. And multiply the 300 times 800 times 500, so the answer is 120 million ml. Divided by 250 times 600, the answer is 150,000. Next, we need to divide the 120 million divided by 150,000. The final answer will be 800 ml.